Is that it? All right, what do they have? What's this variable out here? P. So P was profit, what was it? Population. So look, we're going to get a regression, but we're going to get a natural log regression. So in order to do this, we have to create a base of, what's the natural log base? E. All right. So I'm going to tape this just in case someone needs this. So we're going to tape it, post it to the web. If you guys ever want me to tape, my other classer asks me to tape all the time. So I will try to do taping as much as we possibly can. So I'm going to walk you through the process. So if you hit start, we're going to do it. Ooh, we already hit start. We're going. All right. So what I have to do is I have to take this from the standard form. This is standard form of an exponential equation, right? That's your base. There's your start. And I have to change this into PERT. P to the E-R-T. So I need a base of E in here. All right? So what I'm going to do is I'm going to take just this, just 1.12, and I'm going to change it into E to a ratio. All right? I'm going to say that again. I'm going to change this, do the work on your paper, to E to a ratio. I want to find out what C would be if I changed this to PERT. All right? I could have used anything. I could have used R if I wanted to, but I use C. All right? Just a number we're plugging in there. Now, concept of logarithms is this. Once I put a log on there, it's got the properties of an exponent. And just to review that, we know 2 to the third equals 8. If I put log base 2 of 8 equals 3, is this an exponent now? Yeah. That means all of this, and we'll talk about it today and tomorrow, has the properties of an exponent. Log base 2 of 8 still holds true for all the properties of an exponent. That includes product of a product. What I mean is this. 2 to the third to the fourth is really equal to 2 to the what? 12th power. All right? So I'm going to come over here and show you what we're going to do. And maybe that'll help, but we're going to do this so much, it'll sink in. So if it's a little fuzzy right now, watch the steps. I'm going to do a natural log of both sides. What I just did here is natural log is really log base E of E. That's what I've done. But what's log base E of E? E to what power is E? It's a 1. This, what I just underlined, turns into 1. And since technically it's a power, we never write the 1, but this is a power of 1 to the power of C. Well, power of power means I can multiply, and 1 times C is just C. So C equals the natural log of 1.12. If what I just said sounds crazy, remember this. If you ever want to bring an exponent, a variable that's an exponent down to the base level, you use a logarithm. All right? And if you ever use a log with the same base as the base that's present, it disappears. All right? We used a log with a base of E, so E disappeared, and the variable dropped down. Someone put the natural log of 1.12 in, and please tell me what it is. I'm going to stop right there. It's approximately, squiggly line, 0.113. You guys cool with that? Yep. All right. So now what we're going to do is we're going to plug that back in for PERT. All right. And we're going to do a solution, right, to get our own inverse equation. So I'm going to write it over here. I've got PERT. And PERT means this. We'll keep it as still P. P equals PERT. P equals, what's my starting amount? 62. And now instead of writing 1.12, I'm going to write E to the 0.113 T. Is this still in the viewing window? We're cool? And my goal is to solve for T. So I'm going to solve for T. What's the first thing I have to do to solve for T? Divide by 62. Divide by 62. Which gives me P over 62 equals E to the 0.113 T power. I want to bring that variable to the base level. So what do I do to both sides? I don't multiply. I take the natural log of both sides. It looks like you're multiplying though, doesn't it? Because we're putting ln in front. So I take the natural log of both sides. These guys cancel or become 1. And I have 0.113 to the T right there is equal to the natural log of P over 62. We're almost done. I'm almost solved for T. What do I have? What do I do to both sides?
Divide by
0.113. I want you to think about what I'm going to do right here, because this part's a little confusing. There is a coefficient of 1 in front of this. So when I have a coefficient of 1, I divide it by 0.113. And I'm just going to worry about this part right here and write it as a number. So someone divide 1 by 0.113 and tell me what it is equal to.
8.84.
8.84 times the natural log of p over 62. All right, so I'm going to write that as an equation. Here it is as an equation that you can plug into your calculator. Since we're going to use y and x instead of t, I'm going to write y equals, is this on there? 8.84 times the natural log of p, not p, let's use x over 62. And I would like you to type that into your calculator and see if it also goes through those points. Can you pause that or stop it or do whatever we need to do? We're going to